This presentation is about Mapmonkey, the University of Adelaide geocoding service. I'm Lime Kelly, and the geocoder was developed in partnership with my colleagues. I'm a statistician who developed the address matching algorithm. Danielle and Jared are GIS advisors with extensive experience in geocoding. Andy and Mark are IT programmers and website specialists. To start off with, what is geocoding? Geocoding converts text addresses, possibly containing spelling mistakes, into latitudes and longitudes which can be displayed on a map. For example, here's an address in Adelaide, South Australia, and its location on the map. So why geocode? I'd like to start by setting the scene. Location in today's modern world is becoming critical to many industries and has entered quickly and convincingly into our everyday lives. With the rise in apps using address information such as Google Maps, Uber, various home delivery services, a movement towards connected cities and an increase in research with a spatial component, there was a growing need for accurately geocoded addresses. What do all of these things have in common? Geographic coordinates, latitude and longitude. So why did we develop a geocoding service? As researchers, correctly geocoded information is vital to our research credibility and capacity to undertake spatial analysis that has the potential to uncover patterns and underlying trends in our data, not easily identifiable through more traditional research approaches. Since geocode is the process of matching an address to a set of known addresses, these challenges can make geocoding difficult, if not impossible, for some data. For example, the addresses are not always correctly recorded, non-standard spelling is used, there's an incorrect street type names or simply incomplete address information or vanity addresses are used. So the solution was Mapmonkey. This was developed by the project team as an in-house University of Adelaide geocoder. It can geocode multiple Australian addresses. The user supplies Australian street addresses which are matched to the geocoded national address file or GNAF. It's user-friendly and designed with the end user in mind. No coding or GIS expertise is required, and matching accuracy is explained in plain English. It also has a better match accuracy than many common geocoders. So the matching algorithm, it matches by each state separately, and it uses robust fuzzy string matching on street names and suburbs to GNAF. It is innovative in that it uses the Australian address hierarchy, where postcode is more important than suburb, street name, and finally street number. The probability of a match is calculated at each level and combined to find a final match probability. This overall match probability is categorized into high, medium, and low. The algorithm will match at the highest possible level depending on the supplied address. An exact house match if possible, or otherwise a close house match, street centroid within the same suburb or postcode, or a suburb postcode centroid are the lowest matching levels. So what are the Mapmonkey outputs? First of all, the geographic coordinates, the latitude and longitude, are displayed on a map. The supplied address is provided along with the best match address. The match accuracy as high, medium or low are colour-coded, and indicators for matches at street number, street name and locality postcode are provided with ticks or crosses. The matching level is given, that is house match, close house match, street, suburb or postcode centroid. Finally, multiple addresses can be downloaded in a CSV file along with the matches, and in this CSV file the Australian Bureau of Statistics mesh block code is also provided for house matches and close house matches only. So what are the alternatives? Everyone is familiar with Google Maps, which is great for locating one address because it's a manual process to enter the addresses one by one. To geocode multiple addresses, it requires programming skills to code the Google Maps geocoding API. However, there is a limited free geocoding from this API and only if you create a billing account. Pitney Bowes is a very well-known geocoding service. It's provided services for over 30 years to thousands of organisations. Today, this technology is used to validate addresses worldwide. This map service is only offered through their GIS software, Mapinfo Pro, and it requires setting up every time and is very manual, and it offers no mapping interface to view results. So how does Mapmonkey compare to these two alternatives? Some examples of Mapmonkey geocoding addresses and the output from Pitney Bowes and Google Maps are shown. The less accurate matches are shown in red. No single geocoder matched all the addresses, but Mapmonkey was on par with the others. So overall, our benchmarking indicated that in achieving house matches, Mapmonkey was on par with Google. In fact, it was 0.18% better, and it was 2% better than Pitney Bowes, and this was done on a sample size of 3,294. So what are the next steps? I have my coordinates. What now? Well, first of all, you can display these coordinates using geographic information systems. For example, ArcMap or ArcPro. You can either upload these addresses directly into Google Maps or Google Earth, or you can download open source GIS software. Once you have the coordinates, you can actually do data linkage with them. You can link multiple data sets using either the geographic coordinates. This would be linking to spatial data sets, which also have geographic coordinates. Or you can use the Australian Bureau of Statistics mesh block or SA1 codes to link to other data sets which have SA1 or mesh block on them. This example of research using geocoded addresses was based on work undertaken by the Hugo Centre in 2013. The Red Cross Blood Service wanted to demonstrate how their data could be analysed spatially, given a large proportion of their data contains a location and time component. The graph on the top right-hand side of the screen indicates the percentage of metropolitan donors to population by 2-kilometre road distance buffers to consider the influence of population size or density has on donation likelihood. Distance analysis findings were then used to determine, along the road network, the most appropriate donation site catchment area for each donation site. Once donation site catchment areas were created, these catchment areas were aligned to Australian census boundaries to determine the potential number of eligible donors for each donation site based on age and gender. As the population pyramid indicates, young males need to donate more, and a targeted campaign may have a greater impact and be more cost-effective for increasing the number of people donating blood. For more information, please contact the Hugo Centre for Population and Housing at the University of Adelaide. Thank you for your attention.